is, I think, a very fun. Let me save this. Okay, read this one. Okay, read this one. There's a very basic thing. How to find out that V max, V minimum is asking blocks A and B are connected by a spring. And so try to read. Here's the question is what I'm giving. And kept on smooth horizontal, the blocks are given velocity and released. They're given velocity like this. Maximum elongation, maximum compression, and maximum speed of the block B, maximum minimum speed, and maximum and minimum speed of the block A. So all these things have to be calculated. What is the methodology? What is the methodology? Here, what happened? Both the ground frame as well as the center of mass frame, if you can do this problem, it'll be easy and you'll analyze. I think one problem you do it will be on safer side. Without C frame, I don't think so you can really conclude this particular problem. You need a background of C frame only. So let me start it here. Okay, this initially the relaxed. Okay, they are given velocity V0 and so this is the initial. Okay, now. Okay, we'll start it. So initially spring is relaxed. So first in initial state only. So in the initial state only, what is the velocity of center of mass? So that will calculate speed of center of mass 3mv minus 2mv is equal to 3m plus m v by 5. I'll highlight it because there's a very important data for us. Okay, no. Next we'll proceed to the next part of the problem. So this is about the voice for everyone, or can you hear me clearly?
Sir, now okay, sir. But previously it was lagging a lot, sir.
Voice was breaking, sir.
Voice was breaking. What to do? No.
It's clear, sir.
Now it's clear.
Sir.
Okay, now I'll proceed it. Okay, voice breaking, just you tell me, like we'll wait for some 5-10 seconds, then it'll be good. Okay, no velocity of, so we got velocity of center of mass. Now what is the, in C frame, how do this will be moving? This is the initial diagram, so we have started from here. Velocity of center, we have calculated. No, in C frame, for that in C frame, how the blocks will be moving? We'll calculate velocity of block A with respect to VA minus VC. What is the speed of block A with respect to ground? It is given minus V. Now look at the negative sign, minus V. Velocity of center minus velocity of center plus V by 5. Negative sign is due to this one, VA minus VC, no? So minus CV by 5. So in the C frame, it will move with a velocity how much? Minus CV by 5 towards left. Then what about the block B? Its velocity I calculate VB minus VC plus V minus of V by 5, 4V by 5. In C frame, this is the velocity. Okay, till here it's fine. Now in C frame, so they're moving away. So in C frame, how the motion of these blocks will be? The motion of these blocks will be SHM. Am I right? Go back to SHM idea. So initially, what is the state of the spring? Will be relaxed. In C frame also, this is the relaxed position. Relaxed in the sense x equal to 0. Am I right? So when spring is at its natural, this is the thing. So you have idea of SHM. Again, after half of the oscillation, again, if they come back to the same when the spring is relaxed, how the speed of A and block A and block B with respect to center of mass, VAC should be towards left, no? VAC should be towards right, VBC should be towards left. If it's executing SHM, this is a T equals 0. Exactly after T equal to T by 2, what do you expect? They should come back like this. So VAC will be towards right, VBC will be towards left. I agree this. So then we'll start from here. This is T equals 0. T by 4, what will happen? Spring will have maximum elongation. Got the idea? So they'll have maximum elongation. Then after at T code T by 2, the velocities will be in opposite. It will be VS will be towards right, towards left. Then at maximum compression, then again this will become one time period. So like this in C frame, they're just oscillating. This is the golden statement. You just remember it. You can easily manage this part. You need not to draw so many diagrams in exam. I'm telling this one. As a teacher, I have to explain. I just took help of all this one. This is what in ground frame. If the C frame, I will put in box the discussion. If there is no box, red color, then it's a ground frame. So in ground frame, what will happen? So the moment you give velocity, this will start elongating. So kx1. So velocity of the block VB1. Speed velocity of this block will be VA1. So the speed of both the blocks will decrease. So what do you expect the speed of the block is? At one instant, it should come to rest, no? The any reason for that, sir? Why only this will come to rest? Why not this one? Check initial momentum. 3 MV minus 2 MV. So initial momentum is towards right. So at an instant of time, the momentum should be how much MV. So if you look at that particular thing, this block as momentarily it will come to rest. Is this maximum elongation? The answer is no. This block will have certain velocity VB2. Let it be that one. Now also in all cases, center of mass will be moving with velocity how much? V by 5 only. Velocity of center will be V by 5. Okay, let's calculate now. Okay, this again spring force will act. So what this it will do? First, how the motion of block A will be? It will move towards left, come to intense rest, and will start moving towards right. Then some kx2 will act here, kx2. Again, it's a still elongation only. Then the speed of this block starts increasing. So again, it's elongation. So now what do you expect? So the moment what happens when both have common velocity with respect to ground, this will have maximum elongation. And at maximum elongation or compression, the ground frame, the velocity of the blocks we should be equal to velocity of center of mass. This is the very fundamental part. At maximum elongation compression, the blocks will have common velocity and that is equal to velocity of center of mass. Okay, I agree this. I think till here everyone knows. And what is the speed of the block? Will be V by 5. What is the speed of the block A? Will be V by 5 only. Okay, let's get into the thing now. In C frame, initially relaxed, we discussed, no? Initially when spring is relaxed in C frame, we discussed. In C frame, what happened? They will go. So they'll start moving away. So at maximum elongation in ground frame, this is a situation. At maximum elongation in ground frame, both the blocks will have velocity at that of center of mass. Is it okay? In C frame, how it will be? Let's see this one. At maximum elongation in C frame, what is the state of the blocks? Will be at rest. So here, this is the golden statement of this entire whole discussion. So at maximum elongation, at maximum elongation in lab frame alert. Ground, let me call lab. We don't use usually word use ground. So lab frame it is. In lab frame, blocks will have common velocity equal to velocity of center of mass. Okay, this at maximum elongation in And at maximum elongation, okay, no, this will be in C frame. Blocks A and B will have common, no, will be at rest. Blocks A and B. Okay, this will be at maximum elongation, there's a condition. Okay, now we know it's like SHM, no? Initially mean position, it has gone to extreme. Then after extreme, what happened? It should again come back to the mean position. At mean position in C frame, what happened? Relax. The spring will be relaxed here. So after this, what will happen? The spring force here acting will be great. Will further increase velocity of this. Will further decrease velocity. Velocity of block A will become greater than velocity of block B. Now it will start coming out of maximum elongation. So will be elongation only. After that will be elongation. Then it will attain natural length. So after this sequence, what you should get? The natural length in the ground frame. Then velocity of block A and VB. So VA will be greater than VB. If you want, you can write that also. And in the C frame, how the situation? Spring is relaxed. Relaxed or tell me like what should happen here? The blocks, what happened, will now move towards each other. VAC and VBC. Agree this? So this will be C in C frame. I just put it here. Now let's coming to discussion. What will happen to velocity of center of mass? The center of mass will continue to move with whatever happens here. The center of mass will continue its uniform velocity motion. I'm writing VC. Okay, let's do one thing. What is the speed of the block A? This I don't know how to calculate. I'm using center of mass constant. VAC equal to VA minus VC. This one. What is VAC? Shall I write 6V by 5? From where I brought this? From where this I brought it. Velocity of center of mass plus V by V. From where this 6V over 5 suddenly? Because, sir, from where you brought it, I'll go back. But, sir, it should be minus 6V by 5. Yes, at t equals 0, they'll be moving away. At t equal to t by 2. Again, when they come back to mean position, their velocities should be in opposite direction. You go back to SHM. So VAC should be towards right, VBC should be towards left. So here I'll put that 6V by 5. So I get the speed of the block A with respect to ground this is. I think it is understood now. If I write only VA, it is understood. With respect to lap frame. Similarly, VB, it will be minus 4V by 5. So I got this one. So in what action? It will be moving. So here we thought like it is moving towards right. You look at this one. What is the answer we got? Minus 3V by 5. Don't conclude, don't make this problem generalized. Only what you have to generalize, it maximum elongation compression in lap frame at maximum compression or elongation, both the blocks will have common velocity in the direction of velocity of center of mass. In the C frame, they will be at rest. Oh, sorry, like in the C frame. So what you should say like and all. So initially in what relaxed, the speeds are there in the same thing. What happened? They must have when spring is relaxed. Okay, I got the speed of the block, you see 3V by 5. So what does it mean? What actually happened? So what we expected something like this, no? I got it, minus 3V by 5. Okay, tell me like what's happening to the block B? From relaxed, it will get elongated, maximum elongation, then relaxed. In that particular process, what happens? Somewhere the velocity of block B, if it is negative means somewhere it should have been 0, no? It is moving somewhere towards left here. So therefore, what is the minimum velocity of B? Will be 0. Minimum velocity of A also will be 0. If this were positive, okay, I would have not touched this particular thing. Okay, I agree this. So this much you have. No, the total problem in the ground frame. Okay, this answer 7V by 5. I'll write it. Now you see this in the ground frame. This what happens. It will move. It will come to rest. I'm writing comment. Please look here. Then again it will start moving again at maximum elongation. Both will have common velocity. Then afterwards what will happen? The spring force still will be elongation. VA4 will be greater than VB4. So again it will be elongation. Somewhere what will happen? Now the spring force is acting in such a way that it will come to instantaneous rest. So then again elongation, it will start moving towards left. This will be towards right at one instant. This is what happens here. When the spring is again relaxed, no, this is the condition. Okay, look at the block B. Block B will think that always it will move towards right. No. Now after this, what will happen? Compression will occur. Compression will occur. So now this particular thing again, it may bring it to instantaneous rest. Again, block B. So maximum compression will take place. Both will have common velocity. So what is the state of block B now? It will undergo retardation, comes to rest. Okay, again it will accelerate towards right. Again, velocity will increase and both will have common velocity. Okay, I think the motion of block B is something very peculiar. What is that one? So how the A will go like this? A will be, this is what A, motion of path of A. What about B? B will be so they may test you these things also, path of in lab frame. In center of mass frame, both will move away. Then again, both will approach center of mass. With respect to center of mass, what happens? First, initially, both will move away. Then they'll come to rest. Then again, they'll approach. Okay, this is a path of B. Now, okay, I'm interested to go back to the data. So is it justified minimum speed? Maximum speed of the B will be V only. It can never be more than this. And maximum speed of A will be 7B/5, what we calculated. Okay, now your task question, like, sir, like how you minimum speed in the lab frame where it comes to rest. Okay, that will be the minimum speed. Then, so where it was lagging, I think. No, okay. Can you hear me? Can I continue? Okay, I think some disturbance in the lot of. Okay, how to, sir, everything is fine, sir. We understood. Where is the probability of maximum speed of the block?
Your voice is breaking.
In C frame, I think very easy to, in the C frame only. Be working again. Huh? Oh, what to do? Lagging and breaking. Both are there. Now, can you hear me? Now it's fine. Okay, no. So everything fine. So where is the probability of getting maximum speed? I think in C frame, it will be much easier, no? Come to the, when the spring is relaxed, there only what happens, the probability is there. The probability of finding the maximum speed will be when in C frame, when it is relaxed, come to the C frame, there only you can calculate that very easily. So what I suggest that initial, this idea is very important. Okay, this initial part of the problem is very important. So where there will be a test in C frame at maximum elongation or compression, in C frame there'll be a test. Where do they can have maximum speed in C frame when spring is relaxed? There's the idea. Finish short. I think I should not talk much here. There's a trick of all this problem. So you need not to do so many things in exam. Just to get maximum elongation, both the blocks must have common speed in the lab frame. For the blocks to have maximum speed in C frame when the spring is relaxed. Finish short. Okay, this one. So I just changed it values because in books you do have some questions are there. You pick up one question, analyze once, and get back here. And I think what I concluded now, it's a general you can apply for any of the problem. In books you have where this is a test, only this given velocity, check it. Again, but you can't say the block B in all numericals, the path will be like this. This is something very dangerous. This is a unique. The path of block B is what? Because of the condition. In every problem, the path of block B will be like this. No, we have to analyze. In every problem, path of block A first will move towards left. No, the velocity was given towards left. That's why it is here. So only this is what is not generalization unique for this problem. But what I'm saying that maximum elongation compression blocks will have common speed in the lab frame. Okay, that is correct. There's a generalization. Then the maximum speed of the blocks will occur at natural length of the spring. And in C frame, it'll be very easy to find out. There's the idea. I given total sequence that is there. You can just take help of